Greetings, friends around the world. I'd like to talk to you about the cause of Earth's climate changes that have occurred almost regularly in periods of approximately 100,000 years. There are spikes in the temperature chart. The famous Vostok ice core chart reveals about 5 of these spikes, I believe, in the past 500,000 years. 5 spikes, sharp temperature spikes. Before Vostok, before the ice cores were taken and examined, scientists had been drilling into the ocean bottom, extracting core samples of ocean bottom sediments, and had known that the Earth's temperature regularly spikes approximately every 100,000 years. And it has been doing this literally for millions of years, at least 100 million years. Ocean bottom sediments do not provide detail of changes that occur in shorter periods of time, such as 10 years and 100 years. But it clearly reveals these spikes. And incidentally, these ocean bottom sediments reveal that the Earth has been cooling over the past 60 to 80 million years, getting cooler and cooler and cooler. But as the temperature falls, these spikes occur regularly. We have entered an ice age, but each spike provides a brief warm period. We are in the latest brief warm period called an interglacial, where the ice on the poles recedes. And it has done this repeatedly. The ice on the poles grows and shrinks, grows and shrinks. This is what the ice cores reveal. This is what the ocean bottom sediment cores reveal. The question is, why does this happen? My theory is that there are huge clouds of interstellar hydrogen in the path of our star, the sun, as it moves through the galaxy in conjunction with the other stars. As our sun, a star, moves through these clouds and between these clouds of interstellar gas, which are huge, measured in light years across. These are huge clouds of hydrogen gas, but these clouds are very, very thin. They lack density. There's not much hydrogen there. However, if this hydrogen were to be condensed and to be attracted relentlessly by the sun over a long period of time, measured in hundreds of years, couldn't this additional hydrogen cause the sun to brighten slightly? Some might argue that, oh no, the hydrogen is repelled by the solar wind and the electromagnetic field generated by the spinning of the sun's core. I doubt this. I believe the solar wind is intermittent. It is composed of occasional bursts of subatomic particles, burps, farts. One flare will go in that direction, and then one flare will go in another direction intermittently. It's not continuous. And the electromagnetic field has no effect on neutral hydrogen. An electromagnetic field would only repel charged particles, in other words, ions. So I suspect that this interstellar hydrogen fuels the sun. Fuels the sun. I'm saying F-U-E-L-S, fuels the sun, but only slightly. It's not much hydrogen there, but it's a huge cloud, and if it is condensed and sucked into the sun by the sun's gravitational field, remember that 99% of the mass of the solar system is the sun. It has a powerful gravitational field, and there's nothing to resist this incoming hydrogen. Over a period of 100 years, I suspect this additional fuel could cause the sun to brighten slightly. And this could explain these spikes. These clouds of gas are like clumps with spaces in between. And when we pass between these clumps, the Earth would cool, and we enter another clump of hydrogen gas, which is so huge that it takes thousands of years to pass through it. There's plenty of time for that additional fuel to cause the sun to brighten, in my opinion. I am an amateur. I'm not an expert. I have no degree. I'm just exploring the possibility that the movement of the sun through space, passing through clouds of hydrogen gas, might be the answer to the temperature spikes that you see plainly on these ocean bottom sediment cores, showing that the temperature spikes with a periodicity of about 100,000 years, give or take, more or less, and it changes. And these spikes are not identical. That's because these clumps are not identical. More on this later, but that's enough for an introduction. Thank you for watching.